Okay, question 1. A straight line passes through these points. We want to find the point of intersection of this line with the line y equals 2x plus 5. Well, firstly, what we've got to do is we've got to find the equation of the first line. And so the way we're going to do that is we're going to find the gradient. So m is equal to y2 minus y1, so 29 minus 23. 29 minus 23. Over x2 minus x1, which is negative 8 minus 4. And if I simplify that, well, 29 minus 23 is 6, and negative 8 minus 4 is minus 12. And so the gradient is going to be minus a half. Okay, so that's the gradient of that line. And then we can use the formula y minus y1 is equal to mx minus x1, where x1, y1 is a coordinate point, and of course we can use the coordinate 423 or also this point there. So if I substitute in the point 423, I'm going to get y minus 23 is equal to m minus a half x minus 4. And I think I'll just rearrange this. I'll get y is equal to minus a half x. Minus a half times by minus 4 is positive 2. Now I'm going to add 23 to both sides, so I'm going to get plus 25 there. So now what I want to do is I want to find the intersection of this line with y equals 2x plus 5. That's simultaneous equations. I can just equate the two lines. So I'm going to say 2x plus 5 is equal to minus a half x plus 25. I'm going to add a half x to both sides. So that will become 5 upon 2x, or 2.5x. I'll subtract 5 from both sides, which is going to give me 20. And then I will multiply both sides by 2 and divide by 5. So 20 times by 2 is 40, divided by 5 is 8. So the x-coordinate is 8, and of course I want the y-coordinate as well. So I'll substitute that into the line 2x plus 5. So y is equal to 2 times by 8 plus 5. 2 times by 8 is 16, plus 5 is 21. And so the coordinate of the point P is therefore 8, 21. Okay, then part B, we want to find the distance of P from the origin. Well, what's the origin? The origin is the point 0, 0. And the point P we just found was 8, 21. And so if we want to find the distance OP, that's going to be equal to the square root of x2 minus x1 all squared. So that's 8 minus 0 squared, which is just 8 squared, plus y2 minus y1, which is 21 minus 0, which is 21 all squared. We're going to have 8 squared plus 21 squared. And I think I'll just use my calculator to do that. So 21 squared is 441 plus 8 squared, which is 64. So that's going to give me the square root of 505. And I can simplify that. No, I can't simplify that. But if I write that as a decimal, I will get 22.5. Now I'm just going to have a quick look at the mark scheme to see if they want it as decimals or if they want it as an exact answer. They accept root 505 or 22.5. Both are acceptable. Okay, question 2. This is a discriminant question. Find the non-zero value of k for which this line here is a tangent to this curve here. Okay, well, it's probably a good idea if we just think about what a tangent is. So here, if I've got a curve like that, and I've got a line which is tangent to it, so let me just try to draw that on. So this line here would be tangent to the curve. And what do we mean by that? We mean that there is one and only one point of intersection, right? So there is one intersection point. So it's just touching the curve. So that means if we were to solve these simultaneous equations, right, if we were trying to find the intersection of this line with this curve, what we should get is just one point of intersection and one solution. Well, that means that as we do that working, as we try to find that intersection point, we're going to end up with a quadratic. And that quadratic is only going to have one solution, which means that the discriminant of that quadratic must be 0. So let's just recap that idea for those of you who are not totally sure. When we've got a discriminant, b squared minus 4ac, we've got 3 different alternatives, which is either discriminant is negative, or it's positive, or it's 0. And this is going to determine the number of solutions that the quadratic is going to have, the number of solutions. So if it's negative, there are no real solutions. If it's positive, there are 2 distinct solutions. And if it's 0, you've got 1 repeated solution. Or another way you could write that is to say it's got 2 solutions, but the 2 solutions are the same. So what we're going to do is we're going to say, because this situation here corresponds to the tangent, right? We've got 1 point of intersection. We're going to try to solve these 2 equations simultaneously. We're going to end up with a quadratic, and then we know the discriminant of that quadratic must be equal to 0. So let's get about doing that. So I'm going to set negative 2x minus 6k minus 1 equal to, I'll expand this as well, x squared plus 2kx. And then I'm going to collect everything on one side. So I'm going to get 0 is equal to x squared plus 2kx plus 2x plus 6k plus 1. And I'm going to factorize this out. So I'm going to get x squared plus, open bracket, 2k plus 2x plus 6k plus 1. And I've deliberately decided to write that in a bracket. Now, why have I done that? Because when we've got a quadratic, we typically call the coefficient of x squared a. So a there is equal to 1. The coefficient of x is b. So that's our b, 2k plus 2. And this guy here is our c, 6k plus 1. And what I said a moment ago is we want b squared minus 4ac, the discriminant, to be equal to 0. So that's exactly what I'm going to do. I'm going to get a 2k plus 2. That's my b all squared minus 4 times by 1, because that's a, times by c, which is 6k plus 1 is equal to 0. And I think the best thing to do here is just going to expand everything. So we will get 4k squared plus 8k plus 4, right? Because 2k all squared is 4k squared. 2k times by 2 is 4k, but we've got 2 of them, so that's 8k. And then 2 times by 2 is 4. And if I expand this, I'm going to get minus 24k minus 4 is equal to 0. Well, hopefully what you can see there is you've got plus 4 and minus 4, so that disappears. And then we're going to get 4k squared minus 16k is equal to 0. And this should factorize. We can factorize out 4k to get k minus 4 there. And so that means we've either got solutions k is equal to 0 or k is equal to 4, right? So k is equal to 0 or k is equal to 4. Now, let's just go back, read our question very carefully. We want the non-zero value, right? So that's what the question says. We need to be super careful. And the non-zero value is obviously k is equal to 4. So we can say we ignore that solution. So k is equal to 4 is our only solution. All right, then, question 3. We're told not to use a calculator in this question, which means you need to show all of your working. Okay, that's absolutely key. We've got a cylinder, has got base radius this, 2 plus root 3, and a volume given by this. We want to find the exact value of its height, giving our answer in the simplest form. Well, I think it's a good idea just to draw out what we've got. So I'll try to draw out a cylinder. But there we go, cylinder like that. Not a great drawing, I do beg your pardon. And a cylinder has got radius r, like that, for the bottom circle, and it's got a height of h, like that. So what's the formula for the volume? The volume of the cylinder is going to have the area of the circle on the bottom, which is pi r squared, and then we're going to times this up by h, okay? So what we're going to need to calculate is we're going to need to calculate r squared, and then we're going to need to do a division. Right, we need to find h is equal to v over pi r squared, and that's going to involve us using rationalization, okay? All right, so let's take r first. So r squared is going to equal to 2 plus root 3 all squared, which I'm going to write as 2 plus root 3 times by 2 plus root 3. And if I do that, I'm going to get 2 times by 2, which is 4, plus 2 times by root 3, which is 2 root 3, plus root 3 times by 2, which is 2 root 3, plus root 3 times by root 3, which is root 3 squared, which is just 3. Right? Or if you prefer, you can think of it as root 9, and root 9 is 3. Now, if I add these up, I'm going to get 7 plus 4 root 3. Okay? All right, then. So now I can substitute this into my formula. I can say that h is going to be equal to the volume. Now, what was the volume? It was pi 16 plus 9 root 3. So pi bracket 16 plus 9 root 3 divided through by 7 plus 4 root 3. And then, of course, we've got to remember we've got to times it by pi because it's pi r squared. So here's our pi like that. Okay, well, obviously, first thing is that the pi's cancel out, so that's gone. So then what we've got to do here is we've got to rationalize. Now, how do we rationalize? We've got to use the conjugate. So we look at that thing, the denominator is 7 plus 4 root 3. And the conjugate, therefore, is going to be 7 minus 4 root 3. And so we've got to times the top and bottom by that conjugate. Now, why do we do this? Because basically, if we times through by this conjugate, the square root terms are going to cancel off, okay? And so we're left with a rational, not rational number, a non-surd on the denominator. Okay, so let's multiply out the top. So we have got 16 times by 7. I know it says don't use a calculator, but I'm going to do that just to make sure that my arithmetic is right. So that's 112. And then I've got 16 times by negative 4 root 3. So 16 times by 4 is 64. So that's negative 64 root 3. Then I'm going to have 9 root 3 times by 7, which is 63 root 3. And then I'm going to have 9 root 3 times by negative 4 root 3. Well, let's just think about this. We've got 9 times by 4 is 36. We've got minus 36. And then root 3 times by root 3 is 3. Right, so we've got to do 36 there times by 3. Well, now let's try to figure out this denominator. So we're going to have 7 times by 7, which is 49. Then 7 times by minus 4 root 3 is minus 28 root 3. And then we've got 4 root 3 times 7, which is plus 28 root 3. And then we've got 4 root 3 times by negative 4 root 3, which is going to give us negative 16 times through by 3. Okay, well, hopefully what you can see is on the denominator, the negative 28 root 3 cancels out with the positive 28 root 3. And so now what we've got to do is we've just got to simplify our terms. So on the top, we're going to have 112 minus 64 root 3 plus 63 root 3 is going to be equal to minus root 3. And we've got here 36 times by 3. So 36 times by 3 is 108. So minus 108. And this is all going to be divided through by 49 minus 16 times by 3. Well, 16 times by 3 is 48. So on the bottom, we have got 49 minus 48, which of course is 1. So if we simplify one last time, we've got 112 minus 108, which is 4, minus root 3 divided by 1. So the answer is 4 minus root 3. Okay, so this is question 4. We want to solve the following equation. Well, this is basically going to be using indices rules. So I think what I'll do is I'll start by stating the indices rules. If I've got a to the power of x, all to the power of y, then what I do is I multiply out the powers. So I get a to the power of x times by y. If I've got a to the power of x times by a to the power of y, that's equal to a to the power of x plus y. So I add the powers. And then if I've got a to the power of x divided by a to the power of y, then that's equal to a to the power of x minus y, right? So those are the three things I think that we're going to be using here. So I'm going to start off, firstly, I'm going to expand this top one. So I'm going to use this rule here. This is going to be the same as e to the power of 2 times by x plus 1. Right? So that's using the first rule. On the bottom, what have we got here? Well, the square root is the same as the power of a half. So I can write this as e to the x, all to the power of a half. And then again, I can use the first rule. I can multiply the powers. So this is actually the same thing as e to the half x. So I'm going to write that out. So e to the half x is equal to 10. And then I can use the third rule here, right? Because we've got the division. And so that means that we can subtract our powers. So I'm going to get e to the power of 2x plus 1, which is the same as 2x plus 2, minus a half x. And that's going to be equal to 10. So I think now I'm just going to simplify my, my power there. That's going to be e. 2x minus a half x is 3 upon 2x plus 2 is equal to 10. And then I can convert this into a logarithmic form. So my base is e, so I'm going to be using ln. And my power is 3x plus 3 upon 2x plus 2. So I can write 3 upon 2x plus 2 is equal to the natural log of 10. Well, then it's just a little bit of rearranging, right? I'm going to subtract 2. So 3 upon 2x is equal to ln 10 minus 2. And then I'm going to divide by 3 upon 2, which is the same as timesing by 2/3. So I get 2/3 ln 10 minus 2. So that's the answer in the exact form. And probably a good idea just to key it into a calculator so you give kind of both variants as well. So ln 10 minus 2 times by 2 and then divide by 3. And I get 0.2017. 0.2017. And I'm just going to check what the mark scheme gives so that we're consistent. Yeah, they either give it in exact form or the decimal there is also acceptable. Okay, so here we are in part B, which is a logarithm question. I think it's always helpful to state the log rules before we do this. So I've written them out here. If I've got log A plus log B, that's equal to log A times B. If I've got log A minus log B, that's equal to log A over B. And if I've got log A to the power of P, that's equal to P log A. Now, a little warning here, these rules only work if the bases of all the logs are the same. So for example, if I have log base 2a plus log base 3a, then I can't use this rule. Okay, so how are we going to use this to solve this question? Well, the first thing really is we see we've got one log minus another log. So the temptation is to jump straight to rule 2. But we can't do that because of the coefficient of the log here, right? We're not allowed to do that just yet. We've got to deal with that too. And the way we deal with it is we use the third rule, okay? So if I've got p times by log a, I can bring that p up as a power of a and write it as log base a to the power of p there. So that's exactly what I'm going to do. I'm going to rewrite this as log base 9 y squared minus log 4y minus 9 is equal to a half. And then I can use my second rule. So I'm going to rewrite this as log base 9 y squared divided by 4y minus 9 is equal to a half. Well, now I can convert this into exponential form. My base is 9 and my power is a half. So I know that y squared upon 4y minus 9 is going to be equal to 9 to the power of a half. Now, 9 to the power of a half, right, that's the same thing as the square root of 9, and the square root of 9 is 3. So I can say y squared over 4y minus 9 is equal to 3. And so therefore, if I multiply through, I've got y squared is equal to 12y minus 27. And this thing here is a quadratic. So I can write that as y squared minus 12y plus 27 is equal to 0. And so therefore, if we factorize this, we're looking for two numbers that are going to multiply to give positive 27, and they're going to add together to give negative 12. So that seems to me like we're going to get negative 9 and negative 3, which means our solution is y is equal to 3 and y is equal to 9. So we're just going to check that against our answers. Can y equal 3 and y equal 9? Yes, I think so. All right, then, here we are in question 5. We want to find the equation of the normal to this curve at the point 1, 1. Well, if we want to find the equation of any line, we need two things. One is we need the coordinate point, and the second thing we need is the gradient of the line. Now, we actually have one of those things already, don't we? Because we're told that the point is 1, 1, so we can tick that guy off. So what we now need to find is we need to find the gradient. Well, the way we find the gradient is we differentiate, because differentiation tells us the gradient of the tangent to the curve at any particular point. So if I differentiate, I'm going to get 3x squared minus 14x plus 12. And I'm going to substitute in the point x is equal to 1. So when x is equal to 1, y prime, dy dx is equal to 3 times by 1 squared, which is 3, minus 14 times by 1, which is minus 14, plus 12. Okay? And if we do all of that, well, minus 14 plus 12 is minus 2, and 3 minus 2 is 1. So that's going to tell us the gradient of the tangent there is equal to 1. Now, we want to find the equation of the normal. And what we need to know is that the tangent and the normal are perpendicular. And if two gradients are perpendicular, then their product will be negative 1, right? So the gradient of the tangent times by the gradient of the normal will be equal to negative 1 because they're perpendicular. And therefore, if that's the case, the gradient of the normal will be equal to negative 1 divided by this gradient here. So we've got negative 1 divided by 1, which is just negative 1. Okay, so we've got our gradient now. We've got our point. The point is 1, 1. So we can just substitute into the formula y minus y1 is equal to m x minus x1, where x1, y1 is the coordinate point. So we've got y minus 1 is equal to negative 1, x minus 1. So if we rearrange that, we get y is equal to minus x. Minus 1 times minus 1 is plus 1. And then we add another 1, so that's going to become plus 2, because we move the negative 1 from the left-hand side to the right-hand side. Okay, so that should be the equation of our normal. Okay, so here we are in part B. We want to find the coordinates of the 2 points where the normal cuts the curve again, and giving our answers in this form where a and b are integers. Okay, so this was the equation of the normal. The curve. This is the equation of the normal. So basically what we're being asked to do is to solve simultaneous equations. So I'm going to start by setting these two equal to each other. So we're going to get x cubed minus 7x squared plus 12x minus 5 is equal to negative x plus 2. So then I'm going to move that x and that 2 to the left-hand side. So I get x cubed minus 7x squared plus x, so that's plus 13x, and subtract 2, so that's minus 7, is equal to 0. Now, what we've got here is we've got a cubic polynomial, and we've been asked to solve that. However, if we're a little bit clever, hopefully we should be able to identify one of the solutions already, because we know that this curve is going to be cut by the normal at the point where x is equal to 1, because we have found the equation of the normal to the curve at the point where x is 1. So we should be able to say that x is equal to 1 is a solution, or is a root of this equation. Okay? And of course, the way to check that is we're just going to substitute 1 into the cubic. So we're going to check. We're going to get 1 cubed minus 7 times by 1 squared plus 13 times by 1 minus 7. Okay, and 1 cubed is 1, minus 7 plus 13 minus 7. And if we do all of that, we're going to get 14 minus 14, which is equal to 0, right? So that is definitely a root. Well, then what we can do is we can use our knowledge of the factor theorem, right? And the factor theorem states that if x equals 1 is a root, then we know that x minus 1 is a factor. Okay, so the factor theorem here is really key, right? If a is a root, x minus a is a factor. So if 2 is a root, x minus 2 is a factor. If 5 is a root, x minus 5 is a factor, and so on and so forth. So we know what a root is, therefore we know what a factor is. Well, that means we can do polynomial division to find all the other factors. So I'm going to take my cubic and I'm going to divide through by x minus 1. So x cubed minus 7x squared plus 13x minus 7. I'm going to take this guy and I'm going to divide it all by x minus 1. Okay, now then, how do we do polynomial division? We take this guy, x cubed, he's the leading term, and we're going to divide it by x. So x cubed divided by x is x squared. We then take that x squared and we're going to multiply it by the divisor here. So that will give us x cubed minus x squared. And having done that, our next step is to subtract the bottom equation from the top. Now, just as a point, by the way, I suggest you write your negative sign on the right-hand side. Often I see my students write the negative sign here on the left-hand side. I think that'll be confusing because often then you can think that this is negative x cubed instead. So I think put it on the right, get it out the way, no confusion there. Now then, if we do this, we're going to get x cubed minus x cubed, which is 0, minus 7x squared minus minus, right? So minus minus is a plus. So that's going to become negative 6x squared plus 13x minus 7. Okay, now that means that negative 6x squared is our new leading term. We're going to divide that through by x. Negative 6x squared divided by x is negative 6x. I take the negative 6x and I multiply it through by the divisor. That's going to give me negative 6x squared plus 6x. And again, I'm going to subtract. So negative 6x squared minus minus 6x squared is 0. 13x minus 6x is 7x. And then hopefully we can already see this is going to work. So 7x is our new leading term. I divide it. So the 7x divided by x gives me 7. I do 7 multiplied by x minus 1, which gives me 7x minus 7. And that subtracts to give 0, which is what we should expect because we know that it's a factor. So what does this tell us? It tells us that x cubed minus 7x squared, was it plus 13x minus 7, can now be written in factorized form as x minus 1 multiplied by x squared minus 6x plus 7. So x squared minus 6x plus 7. Okay, well, this is a quadratic factor, and we could try to factorize it, but actually the question basically tells us this is not going to factorize because we're expecting solutions with surds in them. So the best thing here is to use the quadratic formula, right? So we're going to use the quadratic formula, which I'll remind you is minus b plus or minus the root of b squared minus 4ac all upon 2a. Just a reminder to you, by the way, don't use calculators. You can use calculators, obviously, to check, but don't be lazy. You need to write all of your working for the examiner to see, right? So write down the quadratic formula. Make sure that they know that you know what you're doing, okay? All right, minus b. So b is negative 6, so minus minus b is positive 6, plus or minus the root of negative b squared, which is 36, minus 4 times by 1 times by 7, okay, all over 2a, which is 2 times by 1. And that's going to give us 6 plus or minus. Now, 4 times by 7 is 28. 36 minus 28 is 8. So that's the root of 8 there. And we can simplify this. I'll just do this in long steps for those who are not sure. How do we simplify a surd? Well, I'm going to write it as the square root of 4 times by 2, right? Because 8 is 4 times by 2. And the square root of 4 is 2. So I can rewrite this as 6 plus or minus 2 root 2 upon 2. And therefore, if I divide this, I'm going to get 3 plus or minus root 2. And that should be my answer because I am looking for solutions in the form a plus or minus root b, where a and b are integers, right? So my integers there, a is equal to 3 and b is equal to 2. Okay, and that should be my answer. Okay, question 6, we want to find the exact value of this definite integral. Now, the way that I suggest you do this is if we've got a single term on the denominator, generally the trick is we want to expand the numerator and then simplify. So I'm going to try to demonstrate that. So firstly, I'm going to expand this numerator. So x plus 2 squared is going to give me x squared plus 2x plus 2x, that's 4x, plus 4, all divided through by x, dx. And then you need to recognize that I can rewrite this as x squared upon x plus 4x upon x plus 4 upon x dx. Okay, so what I'm doing here is I'm splitting apart the fraction into 3 terms, because then I can simplify. I can simplify and say x squared divided by x is just x, 4x divided by x is 4, and then I've got this term that's left over on the end, 4 divided by x dx. So now what I can do is I can integrate. I'm going to write that as x to the power of 1. So how do I integrate that term? Well, I increase the power by 1. I get x to the power of 2, divide by the new power. So that's how we integrate there. 4 will integrate to give 4x. Now, perhaps it's easier to think about this the reverse way around, right? If I've got 5x, I differentiate it, I get 5. 7x, I differentiate it, I get 7. 10x, I differentiate it, I get 10. So in the reverse order, right? If I've got 10 and I integrate it, I'm going to get 10x. If I've got 7 and I integrate it, I get 7x. If I get 5 and I integrate it, I get 5x. Okay, so that's one way of thinking about it. Now, this guy here is going to cause people all kinds of trouble because the way a lot of people are going to do this is they're going to say this is the integral of 4x to the power negative 1 dx. They're going to add 1 to the power, so they're going to get 4x to the 0, and they're going to divide through by 0. And they're going to wonder what's going on because you can't divide through by 0. That can't be right. Well, in order to integrate this, you need to remember this is actually a different rule, right? If we've got 1 divided by x, that integrates to give ln, the natural log. So this guy here is actually 4 ln x. And if you want a way of memorizing that, there are 2 things. Firstly, if you integrate and you get power of 0 divided by 0, your brain needs to kick in and it needs to say, hang on, wait, that can't be right. There's got to be another way. That's point 1. Second point is, if the power on the bottom of a fraction is 1, then generally you use ln, right? So if the power on the bottom is 1, use ln. That's a helpful way of remembering. Okay, so then what we've got to do is we just got to substitute in the bounds. Now, the way we do this is we substitute in the upper bound 3. So we take 3, we substitute it in. And then what we're going to do is we're going to substitute the lower bound 2, substitute it in, and subtract 1 from the other. So let's do that. I'm going to substitute in 3. So 3 squared is 9, so we get 9 upon 2, plus 4 times by 3, which is 12, plus 4 ln 3. Then what I'm going to do is I'm going to substitute in the lower bound. So I'm going to get 2 squared, which is 4, divided by 2, which is 2, plus 4 times by 2, which is 8, plus 4 ln 2. Okay, so now what I need to do is I need to simplify this. Okay, so how could I do this? Well, 9 upon 2 I'll write as 4.5, plus 12 is 16.5, minus 2 is 14.5, right? So 14.5, and then plus 8 is 22.5. Oh, sorry, beg your pardon. I better be super careful there. I'll write this out in full, actually. 4.5 plus 12 plus 4 ln 3. 2 plus 8 is 10, isn't it? So that's actually minus 10 there. I almost made a mistake there by adding 8 when I should have subtracted 8. Just hopefully should be a cautionary tale for you guys as well, isn't it? It's just so easy to make mistakes just by trying to be too clever and manipulating things too fast. 12 minus 10 is 2. 4.5 plus 2 is 6.5. And then we've got 4 ln 3 minus 4 ln 2. So what I'm going to do here is I'm going to factorize out the 4. So I've got 4 bracket ln 3 minus ln 2. And then I can use the log rule, right? Because log A minus log B is log A over B. So I can write this as 6.5 plus 4 ln 3 upon 2, or 1.5. Okay. All right, then. I think I'm going to see if there's a particular way they want us to write this answer in the mark scheme. That seems okay to me, but let's see what they want. Yeah, 6.5 plus 4 ln 3 upon 2, or exact equivalent, right? So if you see the letters OE in a mark scheme, right? OE means exact equivalent. So, if you were to write this, for example, as 13 upon 2 plus ln 3 upon 2, or 13 upon 2 plus ln 3 upon 2 to the power of 4, all of those things mean exactly the same, so you'll get the full marks, okay? But the way I've written it here is the exact way they've written it on the mark scheme. Okay, hope that was helpful. Okay, here we are in question 7, which is a kinematics question. Before we get into this, I think I'm just going to recap the basics of the kinematics, which I think is given by this diagram. So in kinematics, we've got three basic things. We've got displacement, velocity, and acceleration. And the thing is to remember that they go in that order, right? So displacement, velocity, acceleration. And if we want to go down, what we need to do is we need to differentiate. So displacement to velocity, we differentiate. Velocity to acceleration, we differentiate. And then we remember that integration is the reverse of differentiation. So if we want to go up, if we want to go in the opposite direction, from acceleration to velocity, we would integrate. And from velocity to displacement, we would also integrate. So I think memorizing this diagram is going to be quite helpful, right? Displacement, velocity, acceleration, you differentiate to go down, you integrate to go up. But hopefully also, you should be able to recognize that this should really make sense. Because what is velocity? The definition of velocity is it's the rate of change of displacement. It's a measure of how quickly my displacement is changing, right? So if I was at displacement 10 and then later I was at displacement 15, and I did that in 1 second, right? Then the rate of change of my displacement will be 5 meters per second, right? Because my displacement has changed by 5. I've done it in 1 second. So that's 10 meters per second. What about acceleration? Well, acceleration as well. What's that telling us? It's telling us the rate of change of our velocity, right? How fast is our velocity changing? So if my velocity was 20, and then 3 seconds later, my velocity was 26, well, my change of velocity was 6 meters per second, and I did that in 3 seconds. So my acceleration would be 2 meters per second squared. So what I would encourage you to do is to really know the definition, right? What does velocity tell us? Velocity tells us the rate of change of displacement. Therefore, it is ds dt. What does acceleration tell us? It is the rate of change of velocity. It is dv dt. And if you know that, then you will know this diagram as well. Okay, so try to know the definitions. I think that's helpful. Okay, let's look at the question. So 7, a particle is traveling in a straight line. Its displacement is given by this. Find expressions for the velocity and acceleration of the particle. Well, velocity, as I just said, is equal to ds dt. So what we're going to do is we're going to differentiate s. So if I differentiate 1.5 e to the 2t, how do I differentiate an exponential? Well, the e to the 2t remains. If I differentiate the 2t, I get a 2, and I multiply it through by the front. So I get 1.5 times by 2, which is 3 e to the 2t. Same thing with differentiating e to the negative 2t, right? I differentiate the power, I get negative 2, so I'm going to multiply by negative 2, which gives me minus 4e to the minus 2t. And if I differentiate negative t, that's negative 1t, so it differentiates to give negative 1. Okay, acceleration is basically the same thing. I need to differentiate velocity, so I'm going to take this function here, I'm going to differentiate it again. If I do that, I'm going to get 6e to the 2t plus 8e to the minus 2t, and I differentiate negative 1, I get 0, right? The same rule has just applied here, right? Differentiate that, I get 2, so I multiply through by 2, 6e to the 2t. Differentiate this, I get negative 2, so multiply by negative 2, I get positive 8. Okay, part B, you want to find the time when the particle is at rest. Well, what does rest mean? Rest is when the velocity of the particle is 0, right? So when it's stopped. So what we've got to do is we've got to take our equation for velocity, which we just found, e to the 3e to 2t minus 4e to the minus 2t, minus 1, and we've got to set it equal to 0. Now, the way to deal with this, right, is we've got a negative power here, and so if we want to handle that, get rid of that, we just multiply by e to the positive 2t, because it will cancel it out. And of course, for an equation, if we multiply one side by e to the 2t, then we've got to multiply the other side as well. But of course, on the left-hand side, if we multiply through, we just get 0. Okay, so now I'm going to multiply through. So 3e to the 2t times by e to the 2t is e to the 4t, right? I add the powers, okay? And negative 4e to the minus 2t times by e to the 2t is negative 4e to the 0, and e to the 0 is 1. And this is minus 1 e to the 2t. So I'm going to write it as minus e to the 2t. Now, the key thing to recognize this is actually a hidden quadratic. And to make that clear, I'm just going to rewrite it. I'm going to rewrite this as 3e to the 2t squared minus e to the 2t minus 4. Now, if you're wondering what's happened here, this is one of the indices rules, right? If I've got a to the power x all to the power of y, that's equal to a to the x times by y, and multiply the powers. So I'm doing it in reverse here, right? I've got e to the 4t, which I can rewrite as e to the 2t times by 2. Okay, that's what's happened there. Now, if I was to use a substitution, right? If I say or rather let u equal e to the 2t, then the equation above becomes 3u squared minus u minus 4. And that is a quadratic. And it's a quadratic that should hopefully factorize quite nicely. So let's just give it a go, see if we can get that out. So that'll give me 3u squared. I think... oh dear, I want to get -4, don't I? So I think that'll be -4 there plus 1. And the reason for that is that will give me 3u, and that'll be minus 4u. That will give me -u. And -4 times by +1 is -1. So that gives me two solutions. That gives me u is equal to 4 divided by 3. Okay. And that also gives me u is equal to -1. And therefore, we know that e to the 2t is equal to 4 upon 3, and e to the 2t is equal to -1. Well, the exponential can never be negative, so there are no solutions for that, so we can get rid of that straight away. And then we can get this one by doing the natural log on both sides. So 2t is equal to the natural log of 4 upon 3, and so therefore t is going to equal to half that. It's going to equal to half ln 4 upon 3. And that should be our answer. Okay, so here we are in part C. We want to find the acceleration of the particle at the time t seconds. Well, earlier on in the question, we found the acceleration of the particle. That was in part A. So now what we need to do is we need to substitute in our value for t, which was a half ln 4 upon 3. All right, so we now say when t is equal to a half ln 4 upon 3, we can substitute that in. So we're going to get a is equal to 6e to the power of 2t. So we've got 2 times by a half ln 4 upon 3, which is ln 4 upon 3, right? Because the 2 and a half, they cancel each other out, plus 8e to the minus ln 4 upon 3. Now, really the key thing to understand here is this thing, right? If I've got ln of e to the power of x, right, that's just equal to x. And similarly, if I've got e to the ln x, that's also equal to x. Now, what's the reason for that? The reason for that is that the exponential function and the natural log function are inverse functions, right? They undo each other. So if you imagine that I put a value into the exponential, right? So I put x in here, and I find e to the x. Then I take the output of that and I put it into the natural log. Well, what's the natural log going to do? It's going to undo the operation of the exponential. It's going to take me back to x. And the same thing is true the other way around, right? If I take a value x and I put it into the natural log function, and I take the output of that and I put it into the exponential, then the exponential function is going to undo the natural log. It's going to give me back to x. Now, there's a caveat to that, right? Which is we need to make sure that there's nothing in between the e and the ln here, right? So there can't be any power, right? It can't be 2 ln x or negative ln x or 4 ln x or whatever. So we need to get rid of that negative there in order to use this property. So I'm going to rewrite this as, beg your pardon, rewrite that as 6e to the ln 4 upon 3 plus 8e to the ln 4 upon 3 to the power of -1, right? What I've done there is I've used the log rule, and I've brought that coefficient up as a power. That enables me to use this property here, right? So instead of 6e to the ln 4 upon 3, the e and the ln cancel each other out, so I got 6 times by 4 upon 3. And the same thing here, right? Instead of e to the power of ln 4 upon 3 to the -1, that's just 4 upon 3 to the -1. So now I can hopefully simplify this. So 6 divided by 3 is 2, and 2 times by 4 is 8. Then I've got to deal with this thing here, right? If I've got 4 upon 3 to the power of -1, what happens is that the fraction there flips. So that becomes 3 upon 4. And 8 divided by 4 is 2. 2 times by 3 is 6. And we've got 8 plus 6 is 14. So the acceleration there should be 14 meters per second squared. If you're a little bit unsure about what I've just did there with that power, if I've got a upon b to the power of -1, that's the same thing as 1 over a upon b, right? Because that's what the power of -1 means. And then what I'll do is I'll multiply top and bottom by b to get rid of the fraction on the bottom. If I multiply top and bottom by b, then what I get on the top is 1 times by b, which is just b, and on the bottom, a divided by b times by b, which is just a. So the thing is, if I've got a upon b to the power of -1, then that's just the same thing as b upon a. In other words, it just flips the fraction, okay? I'm just going to check my answers right, because occasionally I am wrong, and it's good to just make sure. Yep, 14 is the answer, okay? Hope that was helpful. By the way, if you are finding these videos useful, please do like, please do subscribe, and share with your friends. All right, then, next question, question 8. A curve has got equation x sine 2x. We want to find dy dx. Okay, now look, the thing to notice here is that we have got one function x multiplied by another function sine 2x, right? And when we've got that, we have got the product of two functions. And when we've got the product of two functions, we need to use the product rule, right? So it is so helpful for you to understand that the word product rule has actually got a meaning to it, right? Which is it is the product of two functions, right? The word product in math means we multiply two things, right? So if I said, what's the product of 3 and 5? It's 15 because we multiply 3 and 5. So here what we've got is we've got the function x multiplied by sine 2x. So we've got the product of two functions, therefore we use the product rule. So in order to do that, what I'm going to do is I'm going to call the first function u, which is x, and the second function v, which is sine 2x. I'm going to differentiate both of these. So u prime is 1 and v prime is 2 cos 2x. Now, why is that? Well, sine differentiates to give cos, okay? But then what you've got here is you've got 2x. So what you need to do is you need to differentiate that 2 and multiply through, right? This is the chain rule. The chain rule is when we've got one function, 2x, inside another function, which is sine x. And when we've got that, we take the function on the inside, we differentiate it, and we multiply through. Okay. Now, what is the product rule? The product rule is v du plus u dv. And I recommend that you memorize it in that order because it's the same order as the quotient rule, which is v du minus u dv. If you memorize it in that order, you're less likely to make a mistake with the quotient rule. So let's just substitute in. We've got sine 2x times by 1, which is sine 2x, plus x times by 2 cos 2x, which is 2x cos 2x, okay? Now, it may seem that my working is very long and you guys can do it much faster, but can I suggest you write it out just like I've done, because then you will guarantee getting the method mark from the examiner. I even suggest you write out the formula for the product rule, okay? Make sure you get your marks, because if you make a mistake here, and it's not clear that you've used the product rule, you will lose both marks instead of just losing one. All right, part B, we want to find the equation of the tangent to the curve at x is equal to pi by 4. If we want to find the equation of any line, we need two things. We need a point on that line, and the second thing is we need the gradient of the line. Okay, now finding the point, we've got the x coordinate at the point, so what we need to do is we need to find the y coordinate, and the way we're going to do that is we're going to substitute into the curve. So when x is equal to pi by 4, y will be equal to, let's go back up, we've got x sine 2x. So y will be equal to pi by 4 times by sine 2 times by pi by 4, which is pi by 2. And sine pi by 2 is 1, because remember we're dealing with radians, and 1 times by pi by 4 is pi by 4. So our point that we're interested in is the point pi by 4, comma pi by 4. So now what we want to do is we want to find the gradient, and the way we're going to find the gradient is we're going to substitute our x coordinate into dy dx. Sorry, by the way, guys, can I just make a point? I often find this quite frustrating with my students, right? You type this into your calculator when you've been using degrees, right? Your calculator is set to degrees, and you get this really weird decimal. And then you type this really long decimal, like 0.47892. If that ever happens to you in an exam, your brain needs to kick in and you need to say, I have definitely gone wrong, right? It's not a decimal. It's not some crazy long thing. My calculator is probably not set to radians, okay? So set it to radians. That's point 1. Point 2, if you're doing differentiation and integration, you must use radians. You've got no choice. The reason for that is the proofs for differentiating those functions rely on radians, right? So you can't use degrees, okay? So that's that as well. So the moment you start this question, set your calculator to radians so that later on you don't forget to do that. Okay, now then. dy dx was sine 2x plus 2x cos 2x. Let me write that down. So dy dx was equal to sine 2x plus 2x cos 2x. Let me just make sure I got that right. Yeah. So when x is equal to pi by 4, dy dx is equal to sine pi by 2 plus 2 times by pi by 4, which is pi by 2, times by cos 2 times by pi by 4, which is pi by 2. Now, sine pi by 2 is 1, and cos pi by 2 is 0. So we get 1 plus 0, which is 1. And we want to find the equation of the tangent. So we can, that's fine. We don't need to find the gradient of the normal by using m1, m2 is equal to negative 1. So now what we can do is the last step, use the formula. Y minus y1 is equal to m x minus x1. And we substitute in our y coordinate, which is pi by 4. And substitute in our gradient, which is 1. And substitute our x coordinate, which is pi by 4. So we end up with y is equal to 1x minus pi by 4. I add pi by 4. So it looks to me like that is the equation. Y is equal to x. Well, let me just double check that against the mark scheme. See if that is right. Yeah, y is equal to x. How extraordinary. Okay. All right. I hope that was helpful. All right. So here we are in part C. Using our answer to part A, find the exact value of this integral. Okay, now students generally find this question to be quite difficult, or this style of question. The key thing is this part here. It says use our answer to part A. So we need to make sure that we go back and think about the significance of part A. Now in part A, what we learned was that if we have x sine 2x, it differentiates to give this thing here, right? Sine 2x plus 2x cos 2x, right? So we learned that if we take this function and we differentiate it, then we get that function. Now, the key principle to understand here is that integration is the reverse of differentiation, right? So if I was to integrate this function, I would go back to my original function here, right? So let me try to recap this. If I've got this function and I differentiate it to get this function, and if I was to integrate this thing, it's going to bring me back to where I started. And that's really the core idea for doing this. Now, in order to make your life a lot easier, may I suggest that you take this derivative here that you found in part A and you immediately write it as an integral. In other words, you write out the following. You say the integral of sine 2x plus 2x cos 2x dx, because you're integrating it with respect to x, is equal to x sine 2x. And then, of course, you've got to add a constant of integration. Now, this thing here, right, is exactly this principle that I've just explained, right? So we're saying that if we differentiate that, we get this, which means that if we integrate this, we're going to get that. So all I've done here is I've just rewritten that in proper integral form. Okay, so the reason I encourage all my students to do that is because this statement here should at least get you 1 mark. It also enables you to see how you can approach the problem, because remember what the problem is. We want to find the integral of 2x cos 2x, right? We want to find that integral. Well, where can we see that inside this thing? Where can we see that? Well, we see it here, right? So this is the thing that we want. I'm going to highlight that, I think. I'll highlight it in green. This is the guy that we want. So my objective is now to separate everything else off and just get that term isolated. And the way we can do that is we can split this integral into 2. I can rewrite this as the integral of sine 2x dx plus the integral of 2x cos 2x dx, right? So I've now split it off. And why is that helpful? Well, because I am able to integrate this thing here. I know how to integrate that. Sine integrates to give negative cos. And then we've got to look at that coefficient 2. We've got to divide through by 2. So we're going to get negative a half cos 2x plus this thing here, which is the integral we're after, is equal to x sine 2x plus c. Well, then what we've got to do, if we want to get this term all by its own, then I need to take that half cos 2x and I've got to bring it to the right-hand side. So therefore, I can write out that the integral of 2x cos 2x dx is equal to x sine 2x plus a half cos 2x plus c. Right? So I now know how to get that integral. And the last part then is I just need to substitute in my bounds, which are 0 and pi by 6. So I'm going to turn that from an indefinite integral to a definite. So the integral between 0 and pi by 6 of 2x cos 2x dx is equal to x sine 2x plus a half cos 2x between 0 and it was pi by 6. I do beg your pardon. That should be pi by 6 there. And if I just substitute that in, I'm going to substitute in the top bound, pi by 6. That's going to give me pi by 6 times by sine. Pi by 6 times by 2 is pi by 3. Okay. Plus a half cos pi by 3, because 2 times by pi by 6. And then what I need to do is I need to substitute in the lower bound, which is 0. Now, just a warning for you, when people substitute in 0, they so often think that everything inside must be 0. But that may not be true, particularly with sines and cosines, right? Because cos 0 is actually 1. So if we substitute in 0 into here, I'm going to get 0 times by sine 0, well, that is 0. And then I'm going to get plus a half cos 0. We know that cos 0 is 1. So now what we've got to do is we need to put this into a calculator, or it'd be better actually if we know our critical angles. So we get pi by 6 times by sine pi by 3, which is root 3 upon 2. The same as sine 60 degrees. And then plus a half cos pi by 3, which is a half, right? Cos 60 degrees, minus a half cos 0, and cos 0 I said was 1. Okay. So now if I was to simplify all of this, what I've got is pi root 3 upon 12 plus a quarter minus a half. And plus a quarter minus a half is minus a quarter. So I can just write that there, minus a quarter. And that should be my answer in exact form. Does it ask for exact form? Let's go up. Yes, find the exact value. Right, so I get pi root 3 upon 12 minus a quarter. I'm just going to check that answer. Let's just see. Pi root 3 upon 12 minus a quarter. Yep, that's correct. Okay, here we are in question 9, which is an arithmetic progression style question. An arithmetic progression has 12 terms. The sum of the first 3 terms is negative 36, and the sum of the last 3 terms is 72. Find the first term and the common difference. Well, I think the key to doing this is just knowing the formula, actually. The nth term of an arithmetic progression is equal to a plus n minus 1d, where a is the first term and d is the common difference. And that's a formula that is on the front of your exam, so you should at least know that it's there on the front of the exam paper at the least. Now, how can we write this information? The sum of the first 3 terms, well, we can say that that is u1 plus u2 plus u3. That's the first 3 terms. That's equal to negative 36. And if we just use the formula, right, then the first term is going to be a plus 0d. The second term is going to be a plus 1d. And the third term is going to be a plus 2d. And that should also make sense, right? Because what we're really saying there is the first term is a. To get to the second term, we add d. So we get a plus d. And to get to the third term, we add another d. So we get a plus 2d. Now, if we simplify all of that, we get 3a plus 3d is equal to negative 36. And hopefully you all can recognize that that's going to simplify to give a plus d is equal to negative 12 if we divide through by 3. Okay, then, The sum of the last three terms is 72. Now, if there are 12 terms in the progression, the last three terms are going to be the 12th term, the 11th term, and the 10th term. So what we can say is we know that the 10th term plus the 11th term plus the 12th term is equal to 72. And so the 10th term, if we use the formula, is a plus 9d. Just scroll down a little bit. A plus 9d. We know that the 11th term is a plus 10d. And we know that the 12th term is a plus 11d. And that's all equal to 72. Well, we've got a plus a plus a. That's 3a. We've got 9d plus 11d is 20d plus 10d is 30d. That's equal to 72. And we can divide through by 3 to get a plus 10d. 72 divided by 3. I'm just going to double check that because my brain, 24. So now what we got is we got two equations involving a and d, and this will be simultaneous equations, right? So we've got equation 1, we've got equation 2. If I do 2 minus 1, so 2 minus 1, then what's going to happen is I'll get a minus a, right? So this minus this is 0. 10d minus d, which is 9d. So I'll write that down. So we've got 9d. And then we've got 24 minus minus 12, which is 36, right? Because minus minus 12 is plus 12. And therefore, d is going to be equal to 4. And if we've got d is equal to 4, we can just substitute in, can't we? A plus 10 times by 4 is 40, is equal to 24. And therefore, a is equal to 24 minus 40, which is going to be negative 16, right? So our first term should be negative 16. Our common difference will be 4. Okay, here we are in a geometric progression question now for part B. The first three terms of a geometric progression are 1, 1.2, and 1.44. Find the smallest value of n such that the sum of the first n terms is greater than 500. Well, I think the first thing is just write down the formulas. These are found on your exam paper at the front. So the nth term is a times by r to the power n minus 1, where a is the first term, r is the common ratio. And the sum of the first n terms is either this, a times by 1 minus r to the n over 1 minus r, or if we were to multiply top and bottom by negative 1, that is the same as a r to the n minus 1 over r minus 1. Now, let's just have another look at this geometric progression here, 1, 1.2, 1.44. I think it'd be better to rewrite that in fractional form as 1, 12 upon 10, that's the same thing as 1.2, and 144 upon 100, which is the same as 1.44. Hopefully what you can recognize is that 144 is 12 squared and 100 is 10 squared. So actually we can rewrite this as 12 upon 10 all squared. Right now, of course, you could use a calculator to find the common ratio, but I just think it's quite neat to be able to do that because if we look at that, we can straight away tell the first term is 1 and the common ratio is 12 upon 10. Okay, so now what we can do is we can use the formula. We want the sum of the first n terms to be greater than 500. So that's the same thing as saying we want a bracket r to the n minus 1 over r minus 1 to be greater than 500. So now we just substitute in our value for a and r. A is 1. On the top, we're going to get 12 upon 10 to the power of n minus 1. Divided by 12 upon 10 minus 1. Well, that's 12 upon 10 minus 10 upon 10, which is 2 upon 10. Must be greater than 500. So we can multiply both sides by 2/10. So it'll give us 12 upon 10 to the power of n minus 1 must be greater than 500 times by 0.2. So 500 times by 0.2. That gives you 100. And if we add 1 to both sides, we get 12 upon 10 to the power of n must be greater than 101. And probably the best thing is just to log both sides, I think. So if we log both sides, we get log 12 upon 10 to the power of n must be greater than log 101. We can use the log rule to bring that power down to the front, make it a coefficient. So we get n log 12 upon 10 is greater than log 101. Well, log of 12 upon 10, which is log 1.2, right? That's still a positive number, right? So if we divide both sides through, we don't have to flip the sign of the inequality. So we're going to have log 101 over log 12 upon 10, which is log 1.2. And so then we just got to put that into our calculator. So I'm going to get log 101 divided by log 1.2, and the answer I get for that is 25.3. So we want n to be greater than 25.3, but of course we need to remember that we can't have decimal points, right? Because n is only integer values, right? It's the first term, second term, third term, fourth term. So n must be greater than the next value up, which is 26. Okay, so we need to write a final statement like that, which is n must be greater than 26 in order for the sum to be greater than 500. Okay, question 10, which is an identities question. Now, the whole point of an identity, right, is we're not trying to solve an equation. We're not trying to find x. What we're trying to do is show that the left-hand side is the same thing as the right-hand side. And in this question, what we're asked to do is we're asked to write cot x and tan x in terms of cos and sine. Well, the first thing to understand is that tan x is the same thing as sine x divided by cos x. By the way, if you've ever been unsure why that's true, right, hopefully you would have learned that sine is opposite over hypotenuse and that cos is adjacent over hypotenuse. So if I've got opposite over hypotenuse divided by adjacent over hypotenuse, and I multiply top and bottom by the hypotenuse h, then what I'm left with is O upon A, which is the same thing as tan, right? So that's the reason for that, if you were ever wondering. And cot, right? Cot is the same thing as 1 divided by tan x. Okay, 1 divided by tan x. If you, again, wonder about cosec, sec, and cot, the key is always to look at the third letter, right? So 1, 2, 3. The third letter is t, so we have got tan x there. And of course, if cot is 1 divided by tan x, that means we can rewrite that as cos x divided by sine x. Okay, that's the big idea. Now, let me write out the left-hand side of the identity. So the left-hand side is sine x, s over 1 minus cot x. So cot x is cos divided by sine, plus cos x, which I'll call c, over 1 minus tan x, which is 1 minus sine upon cos. I know it's a bit lazy, but I do write sine as s and cos as c. I just find it easier to help me to do the algebra without it looking all messy with writing sine x and cos x all the time. But you should probably write somewhere on the side something like let s equal sine x and c equal cos x, just so you're clear with the examiner. Okay. All right. Now, what I'm going to do is I want to get rid of these fractions on the bottom. Oh, sorry. I miswrote that, right? That's sine divided by cos. Okay, sine divided by cos. If I want to get rid of the fraction on the bottom, then for this guy, I'm going to need to multiply top and bottom by sine, right? So I'm going to take this guy, multiply the top by sine, and multiply the bottom by sine. And for this guy to get rid of the fraction, I've got to multiply the bottom by cos, which means I've also got to multiply the top by cos. So if I do that, for the first fraction, sine times by sine is sine squared. And on the bottom, if I multiply through by sine, I'm going to get sine minus cos. For the second fraction, cos times by cos is cos squared. And if I multiply through on the bottom, I'm going to get cos minus sine. Okay? Now, what are we being asked to show? We want to show this is the same thing as sine plus cos. Oh, how would I want to do this? I mean, I guess I could cross multiply. Yeah, I'll do that. So, no, actually, I won't do that. What I will do is I will multiply top and bottom of this guy by -1. Okay, that's what I'll do. Because if I do that, I'm going to get negative sine squared over cos minus sine plus cos squared over cos minus sine. Okay, so I'm going to do it like that. So that means I can rewrite this as cos squared minus sine squared over cos minus sine. Okay. And cos squared minus sine squared, well, I can rewrite that as cos minus sine times by cos plus sine, because that's the difference of two squares, over cos minus sine. And then hopefully you can recognize that top and bottom have got a common factor of cos minus sine, so disappear, disappear. And what I'm left with is cos plus sine, or cos x plus sine x, which is the answer we are asked to show. Okay, those questions are generally not easy, but you know, with a little bit of working, you should be able to get there. I suggest as well, sometimes when you get stuck on these questions, just get a new sheet of paper and just try it again a different way. It's often a lot easier than going back over your old working and seeing if you can fix that, right? Just try it again, come back to it at the end of the exam, something like that, okay? Because they are not easy. Right, so here we are in the last question of the paper. Solve the equation 9 cot x plus 3 cosec x is equal to tan x. Well, I think we need to replace cot with 1 divided by tan, cosec with 1 divided by sine, and so on and so forth. Now, I think it's helpful at this point we just recap what cosec, sec, and cot are. So we've got cosec, sec, and cot. And always we want to look at the third letter for these guys, okay? So cosec, 1, 2, 3, the third letter is S, and so that's 1 divided by sine. If we've got sec, the third letter, 1, 2, 3, C is C, so we've got 1 divided by cos, okay? And then for cot, the third letter, 1, 2, 3, T, so that's 1 divided by tan, okay? And we should also know the identity that tan x or tan theta is equal to sine theta over cos theta. And therefore, that means that cot, which is 1 divided by tan, is going to be the inverse of that. It's going to be cos theta over sine theta. Okay? All right, then, how can we use this in this equation? Well, I can replace the 9 cot x, I think, with 9 cos divided by sine. I'm going to replace the cosec with 1 upon sine. So 3 cosec becomes 3 upon sine. And I'm going to replace the tan with sine upon cos. And what I'm going to do is I think I will multiply both sides by sine and also by cos. That's going to get rid of these fractions here. So I'm going to multiply that side by sine cos. I'm going to multiply this side too as well by sine cos. Now, if I do that, I'm going to get 9 cos squared. Why is that? Sorry, 9 cos squared. It's slightly sloppy writing. 9 cos squared. Why is that? Well, because if I've got sine cos and I times it by cos upon sine, the cos are going to multiply. That's going to give me cos squared, and the sines are going to cancel out. So that's gone there. And same with this guy. If I've got 3 upon sine and I times it by sine cos, the sines cancel off, and I'm left with 3 cos. And over here on this side, if I've got sine upon cos and I times it by sine cos, I'm going to get sine squared, and the coses are going to cancel off. Now, I've got coses on the left-hand side and a sine squared on the right-hand side. So I think what I'll do is I'm going to use the identity that sine squared is 1 minus cos squared, okay? So hopefully you should also know, along with the identity that tan is sine upon cos, we've got the identity that sine squared plus cos squared is equal to 1. And that means I can rewrite cos squared as 1 minus sine squared and sine squared as 1 minus cos squared. So here what I've got is 9 cos squared plus 3 cos is equal to 1 minus cos squared. So if I rearrange that, I've got 10 cos squared plus 3 cos minus 1 is equal to 0. And that's a quadratic equation. And hopefully that should factorize, but I'm not sure it will just by looking at it. So I think what I'll do is I'll use the quadratic formula. So cos is equal to minus b plus or minus the root of b squared, which is 9 minus 4, a, which is 10, c, which is negative 1. Oh, it is going to factorize. Oh, that's quite nice. All upon 2a, which is 2 times by 10. So if I was to simplify this, I'm going to get negative 3 plus or minus. So that's going to be 9 plus 40, square root of 49, which is 7, all upon 20. And if I did negative 3 plus 7, that's going to give me positive 4. So I would get 4 upon 20. And if I did negative 3 minus 7, that gives me negative 10. So negative 10 upon 20. So I've got two answers here to think about. I've either got the answer that cos x? Cos x is equal to 4 upon 20, which is the same thing as a fifth, or cos x is equal to negative half, because negative 10 upon 20. Okay, then. So we want to be able to solve these questions. Now, there are a couple of ways to do this. We could use the graph of cos x, but I think it may be better here to use the unit circle. So I'm going to draw out the unit circle. A unit circle is a circle with radius 1. Okay, right, like that, like that, like that. Okay. And I'm going to try to explain this method more thoroughly in another video, but hopefully you should be able to get the basic idea here. If I got a circle with radius 1, like that, essentially, when we're trying to solve cos x is equal to a fifth, that's the same thing as saying, where is the x coordinate equal to a fifth on this unit circle, right? So essentially what I'm saying is cos always corresponds to the x coordinate on the unit circle, and sine always corresponds to the y coordinate on the unit circle. So if I'm trying to solve cos theta is equal to a fifth, what I'm really asking is, what angle theta on the unit circle gives me an x coordinate of a fifth, right? So instead of cos, I say, where is the x coordinate equal to a fifth? So I'm going to put that here. Here's a fifth. I can draw a line, I guess, that goes through like that. So what I'm looking for is I'm looking for these two coordinates here, because those are the two coordinates on the unit circle that give me a fifth as the x coordinate. And that means I can then find this guy by using my calculator. I can do cos inverse, so I better make sure my calculator is set to the right mode, to degrees. I can do cos inverse of a fifth, and that's going to give me 78 degrees there, 78 degrees, or 78.5 degrees. And by symmetry, that means that this angle here is also 78.5. Okay, so I've got my first solution is that the angle x is equal to 78.5. And because this angle here is 78.5, I can say that this angle that takes me from the x-axis all the way around to here, so if I was to draw that out a bit more neatly, that would be that whole angle, must be 360 minus 78.5, right? Because it's one full rotation minus that. And so that's going to give me 281.5. Okay, so I'm going to write that down. 281.5. Okay. All right, then we got to solve the next equation. Now, this guy is, sorry, that should be a half. We're trying to solve where cos x is equal to negative a half. Well, on the unit circle, that corresponds to trying to find where the x coordinate is negative a half. And the x coordinate on the unit circle is going to be negative a half roughly there. So that's negative a half. And so in this case, we're interested in finding this coordinate and that coordinate. Okay, so let me just tidy this up now. Let's kind of get rid of all the things we don't want. So let's get rid of that. Let's get rid of that. All that. Sorry about the mess. Okay, get rid of that. Okay. What I'm now interested in finding is I'm interested in finding this angle that takes me to there and the angle that takes me to here, right? So I want to find that angle. And then after that, what I want to do is I want to find that angle there. Now, I can find the first one just by doing cos inverse again. So I do cos inverse of minus 0.5, and that gives me 120. So I get x is also equal to 120. So that's this angle here. And how do I get the blue angle? Well, what I can do is I can say by symmetry, I know that that angle there must also be 120 degrees, right? Because this point and that point, they're reflections of each other in the x-axis. So what's the blue angle? Well, the blue angle is going to be one full rotation. So it's going to be 360 degrees minus 120. So if I do 360 minus 120, I will get 240 degrees. Okay, so 240 degrees. I think that should be all of my answers, because that's everything from 0 to 360. So I'm just going to check the mark scheme, see if that is right. So they want to have 78.5, 281.5, 120, 240, and no extras in that range, right? If there are extras, you can't get the mark, okay? All right, now I know that method, a lot of people kind of use the quadrant method, and my point is that the quadrant method actually comes from this unit circle idea, right? So it's much better if you can to try to understand the unit circle. But I get that if you've only seen this for the first time, then that's going to seem just like magic, right? It's completely inexplicable what I've done. So what I'm going to try to do is I'm going to try to create another video in which I'm going to explain this method fully. And the reason I'm going to do that is I think if you get a handle on it, actually these questions should become quite straightforward. So watch out for that. But there is one other way that you could do this, which I will also indicate now. And that other way is to use the cosine graph. Okay, so I'm going to try to draw the cosine graph here. The cosine graph looks like this. Oh, nice. Sorry, I better draw that a bit better. Cosine graph looks kind of like that. Sorry about this. I'm not so good at drawing like this with the tablet. Oh, my days. Okay, like that. And you should hopefully know that one wave is 360 degrees. And so that'll be 180, that'll be 90, and that'll be 270 there. And that's 1 and minus 1. So this is the graph of y is equal to cos x. And what we're trying to do is we're trying to find where cos x is equal to a fifth. So if I was to do that, that's like drawing a horizontal line here where y is equal to a fifth. And we're trying to find the intersections of that line with the curve. Well, if we use our calculator, we'll get the first value, which was 78.5, right? So that guy is going to be 78.5. 78.5. And hopefully what I hope you'll notice is that this point here is a reflection of this point here in the line x is equal to 180 degrees, right? These two are reflections of each other. Now, what does that mean? It means that this point here is a reflection of that point there. So whatever this distance is, which is 78.5, would have to be the same as whatever that distance is, which would also be 78.5. So this angle here in red would have to be 360 degrees minus the 78.5. Okay, because that is symmetrical with that, and that is symmetrical with that. Therefore, that distance, 78.5, is the same as that distance, 78.5. And we could do the same thing as well when we're trying to solve cos is equal to negative a half. So I could draw a line through there. That's where y is equal to negative a half. Negative a half. And so then we're trying to find this value here and this value here. And again, that will be 120. And for with a similar argument, this angle would be 360 minus 120. Okay. Now, guys, I recognize that the way I do it is more detailed, maybe more involved than what you're used to. I see so many of my students using the quadrant method, and I ask them, what are they doing? Why does it work? And basically, no one can really convincingly explain to me why what they're doing works. What I would say to you is, in add maths, everything is really about understanding. It hinges on understanding. You do not want to do something that you do not understand. So as much as you can, even though it's difficult, you want to strive to make sure you understand what you're doing and why you are doing it. If you can do that, questions that seem incredibly difficult and complicated become actually quite straightforward. But it is hard work to get there. Okay. All right. So I'm going to upload some videos, hopefully explaining that in a little bit more detail. Yeah, I wish you the best of luck. If you are finding these videos helpful, by the way, please do like, please do subscribe and share with your friends. There will be more coming soon.